Hello, my dear students. Welcome to lecture number 9 on the topic Force and Newton's Laws of Motion. In the last period, we solved a few problems. In this session, we are also doing the same. By that, we can end this chapter. So let us begin with the next problem, that is a hammer of mass 500 gram, a hammer of mass 500 gram, moving at 50 meter per second velocity, strikes a nail. So, a 500 gram hammer moving at a velocity of 50 meter per second strikes a nail. The next point, the nail stops the hammer for a very short interval of time of 0.01 second. So nail is stopping the hammer in a very short interval of time, that is 0.01 second. What will be the force of the nail? What will be the force of the nail on the hammer? This is the question. So let's try to write the given parameters from the problem. So hammer is having the mass, therefore M, which is equal to 500 gram. So 500 gram means it is equal to 500 into 10 to the power minus 3 kilogram. So this is the conversion from gram to kilogram, which I already discussed in the previous class. And we have the initial velocity u is equal to 50 meter per second. That is given, and you have to take that v, the final velocity, as 0 meter per second. They did not give this parameter of v. That is from our understandings, because using the hammer you are striking the nail, therefore I can take its final velocity as 0 meter per second, and time is mentioned, t is equal to 0.01 second, which is equal to 100 second. It can be written as 10 to the power minus 2, that much of second, which is equal to 10 to the power minus 2 second. So 0.01 second means it is 1 divided by 100 second. 1 divided by 100 means 10 to the 1 divided by 10 to the power 2, which is equal to 10 to the power minus 2 second. The question is the force of the nail on the hammer. Keep in mind, they are not asking the force of hammer on the nail. It is opposite to that. The force for a short interval of time of the nail on the hammer. Please take care of each and every word given in the problem. I hope you are following my directions correctly. So these are the things they have mentioned, and asked question was, what will be the force of the nail on the hammer? Therefore F, I can write force of the nail N on the hammer, NH I can abbreviate it as, so which is indicating that force of nail on the hammer, FNH. This is for our understanding, otherwise you keep F as it is, no problem. Solution. So what they asked for, They asked the force of nail on the hammer. So using the formula, just using this formula, using Newton's second law of motion, Newton's second law of motion, that can be written as F is equal to ma. It can be written as F is equal to mv minus u divided by t. Therefore, I can write this much, then substitute the value. So this equation can be taken with respect to our problem as nh. So F nh is equal to m, that is mass of the hammer, that is 500 gram. Therefore 500 into 10 to the power minus 3, that much of kg. You keep kg as it is, no problem. And v minus u, v is 0, minus u is 50 meter per second. So you take it meter per second common, no problem. Divided by how much? 10 to the power minus 2 second. Okay. So it can be written as F and H, means the force of the nail on the hammer. So you just take the numericals one side, 10 to the powers one side, unit to the other side. By that I can write 500 into 0 minus 50 means minus 50 into 10 to the power minus 3 divided by 10 to the power minus 2. Okay, so kg meter per second can be brought to the denominator. By that s into s becomes s square. So kg meter per second square is nothing but Newton. I'll put it later. Therefore I can write F, the force of nail on the hammer, which is equal to 500 into minus 50 into minus 3, that can be written as minus of 25,000 into 10 to the power minus 1, because if you solve it out, so 10 to the power this much and 1 left out here, therefore I can write 25,000 into 10 to the power minus 1, that much of Newton, and hence I can write F and H, which is equal to minus 2500 Newton, because divided by 10, that leaves the cancellation of this 0, you left out with 2500 Newton. So you got the value negative. Keep in mind, force is a vector quantity, but particularly in this case, in this problem, that is the force of the nail on the hammer. Remember, this is opposite to that, opposite to the force of hammer on the nail. Therefore I took it as negative. The negative term arises due to the opposition offered by the nail on the hammer. If it is regular, it is positive. The force of the hammer on the nail is maybe plus 2500 Newton, but the asked question was the force of the nail on the hammer, which means that is negative, and hence the force is given by minus 2500 Newton. I hope you got this problem clear. Let us move to the next problem, that is a motor car of mass 1200 kg is moving along a straight line with a uniform velocity of mass, uniform velocity, that is 90 kilometer per hour. Its velocity is slowed down to 18 kilometer per hour in 4 seconds by an unbalanced force. A motor car of mass 1200 kg is moving along a straight line with a uniform velocity of 90 km per hour. Its velocity is decreased to 18 km per hour in 4 seconds by the application of an unbalanced force. Calculate the acceleration, change in momentum, and magnitude of force acquired. So these are the three parameters they asked for, three physical quantities they have asked for here. Acceleration you need to find out, change in the momentum, as well as magnitude of force acquired by the motor car. Okay, so what are the given physical quantities here? Number one, that is mass of the car. M is given, mass of the car, which is 1200 kg. Then it is moving with initially, that is with uniform velocity of 90 km per hour. It can be taken as initial velocity 90 km per hour. That can be written in terms of a meter per second as 90 into kilometer per hour. It is simply taken as 5 by 18 meter per second. I already solved in the previous problem based classes, so that can be written directly in terms of meter per second. Therefore you can go on solving. That is simply 18 ones are 18 fives are, therefore 5 into 5, 25 meter per second. So this is the initial velocity of the motor car in terms of meter per second. Similarly, by the application of an unbalanced force, its velocity is slowed down it into 18 km per hour. That can be taken as V, therefore 18 kmph, kilometer per hour. So 18 into 5 by 18, that gives you 5 meter per second. So that will be your final velocity V in terms of meter per second, and time is given, which is 4 seconds. So 4 seconds will be the time. Therefore you need to calculate the acceleration of the motor car is equal to how much. Similarly, change in momentum, so that can be taken it as mv minus mu, that is change in momentum, which is equal to how much. And magnitude of force acquired means magnitude of force, which is equal to how much. These are the these are the parameters we need to calculate. So first step is to solve for acceleration. So solution part number one. For the solution, the first step is to find or to calculate acceleration A. For that, you are having the simple equation from motion, one of the equation of motion, that is A equal to V minus U divided by T, which is equal to V means that is 5 meter per second, U means 25 meter per second. You take it common of meter per second divided by 4 second of time, and hence A is equal to minus 20 divided by 4 meter per second. By second means meter per second square. That much of acceleration. 4 ones are 4 fives are, therefore acceleration is minus 5 meter per second square. So this is the acceleration of the car. Okay, so the negative term indicates that the motion of the car and the applied force are opposite to each other. Therefore, A is taken as negative 5 meter per second square. Okay, now second step is to find the change in momentum. To find change in momentum, so change in momentum can be expressed as momentum of final momentum minus initial momentum, that can be taken as mv minus mu, which is equal to, it can be solved as m v minus u. Therefore, it just make use of the given values. M is 1200 kg, so 1200 kg v minus u, that is already known. I think you just take it as 5 meter per second directly. Sorry, meter per yes, that is meter per second. Therefore 1200 into 5 means I'm sorry, make me pardon, this is wrong. It is v minus u. Therefore I can write it as 5 minus 25 meter per second in common. So 5 minus 25 means that is 1200 into minus 20 kg meter per second. So 1200 into minus 20, which can be written as minus 24,000 kg meter per second. This has to be the change in momentum of the car. So you got again the value of negative. The last part we are calculating, that is the force, the third parameter. So third parameter force can be written as, to find the force, so using Newton's second law of motion, F is equal to ma. So you already got the acceleration, so make use of that. Mass is 1200 kg into acceleration, which you already got, that minus 5 meter per second square. So 1200 into minus 5, that much of kg meter per second square. So you left out with minus 6000 Newton. So minus 6000 Newton will be the force. So they asked the magnitude of the force. They did not ask about the direction. If it is negative, means they are opposite to each other. The motion of the car and the applied force both are opposite to each other. Therefore, the negative term rises here. But they asked is the magnitude of the force. Therefore, I can write it as mod of F. So mod of F means magnitude of F. Therefore, you can skip this. So you can write directly as minus 6000 Newton, which is equal to anything inside the mod. As per the mathematical rule, it can be taken as positive. That is one of the rule. So don't get confused. Okay. So 6000 Newton will be the magnitude of force. I hope you got this problem correctly. So the next question, or the next problem, you say a bullet of mass 25 gram is fired horizontally with a velocity of 150 meter per second from a pistol of mass 2 kilogram. A bullet of mass 25 gram, which is fired horizontally with a velocity of 150 meter per second, and the pistol having the mass of 2 kilogram, find the recoil velocity of the pistol. So you need to find out the recoil velocity. So you need to understand this problem right, because every problem has its own meaning, and therefore you need to find the suitable formula. So with respect to given parameters, you need to choose the proper formula. Okay, this is the problem based on the conservation of linear momentum. So the up to the previous parts we understood from Newton's second law, most probably the change in momenta, or you may call just linear momentum. This is the applied part, therefore you need to take care of such problems. I hope you are getting my words loud and clear. Now what they have mentioned, they have given the mass of the bullet, mass of the pistol, and the velocity of the bullet. Therefore you need to write all these things, by that you can get the things right. So recoil velocity means the velocity of the pistol after firing. So if you fire a, assume this is a pistol, assume that this is kind of a pistol. I am not a good artist anyway. So if it is, we all know that it has bullet in it. So when you fire that bullet, the bullet is moving with the some velocity, that is 150 meter per second, and it is having the mass, bullet is having the mass of 25 gram, and it is having the velocity of 150 meter per second. So it is having the mass of 2 kg you can take. So this is 25 gram, and it is moving with a velocity of 150 meter per second, no problem. So after firing, this pistol must move against to the motion of the bullet, as per the Newton's third law of motion. For every action there is equal and opposite reaction. That part is known for us. So if the action is done on the bullet, means reaction has to be on the pistol in this case. So let us try to write the parameters given. So first point, that is mass of the bullet. I'll take it as m1, mass of the bullet as m1, which is 25 gram. That can be converted in terms of kg as 25 into 10 to the power minus 3 kg. Okay, and we have m2, that is mass of the pistol. M2 is equal to, that is 2 kilogram. So that's why I converted the mass of the bullet in terms of gram to the kilogram. Okay. Next point, initial velocity of the bullet. So I'll take it initial velocity u1 is equal to 0. That is the initial velocity of the bullet. For the reason I am writing, it is taken from our understanding. So when you are firing a bullet from a pistol, means initially its velocity is 0. Therefore u1 in this case is taken as 0. Similarly, the final velocity is already mentioned, the velocity which is the bullet which is fired at 150 meter per second. Therefore I can write it as v1, the final velocity number 1, that is 150 meter per second. So the next step is to initial velocity of the pistol, that is taken as yet again 0, because before firing pistol is also at rest. That is again taken from our understandings. Then we need to find out V2, the recoil velocity. After the firing, what happens? This pistol moves back. In what velocity it is coming back, we need to calculate. That is known to be as recoil velocity of the pistol. So this problem is a bit complex because conservation of law says that m1u1 plus m2u2, which is equal to m1 plus m1v1 plus m2v2. This is a long expression. Therefore, we need to consider all the proper parameters taken correctly. I hope you are getting my words clear. Now, so let's have the solution for that. As I already mentioned that this is the problem based on the conservation law of momentum. Therefore, I can write using the conservation law. Using the conservation law of linear momentum, or you write simply momentum, no problem. That is m1 u1 plus m2 u2, which is equal to m1 v1 plus m2 v2. So this is a long expression, therefore choose the proper values. This can be done only when you understood the problem correct. Okay, so we want this v2, therefore just rearrange the terms. So what you have to do, sending this m1 v1 on the left hand side, by that I can write m1 u1 plus m2 u2 minus m1 v1, which is equal to m2 v2. So only I sent this m1 v1 to the left hand side, by that I can write it freely for v2. So sending this m2 on the denominator of LHS and sending 1 from this side by the cross multiplication technique, so I can write v2 as m1 u1 plus m2 u2 plus minus m1 v1 divided by m2. So this is the equation for v2. Just try to solve that. So sending m2 all for all the three here, by that I can write it as v2, which is equal to m1 u1 divided by m2 plus m2 u2 divided by that is m2 minus m1 v1 divided by m2. So for this m2 get cancelled, u left out with for v2. Sending this whole term to other side, first you write m1 u1 divided by m2 minus m1 v1 by m2. You just left only with plus u2. Okay, now m1 by m2 common here, just you take a common m1 by m2, which is simply u1 minus v1 plus u2. Okay, therefore I can write v2 as m1 u1 minus v1. This is whole divided by m2, no problem. Then plus u2. So this is the formula used to calculate the recoil velocity of the body as such pistol. Okay, V2 which is equal to M1 into U1 minus V1 divided by M2 plus U2. Now substitute all the values into this expression to get the recoil velocity of the pistol. Okay, we have the formula of V2 which is equal to M1 in the bracket U1 minus V1 divided by M2 plus U2. So M1 is taken as, that is mass of the bullet, 25 into 10 to the power minus 3 kg, that is M1. You keep it in bracket, and U1 as 0 minus V1, that is 150 meter per second, and divided by M2 means that is mass of the pistol, that is 2 kg, plus U2. U2 is again taken as 0. So try to solve this. I substituted all the values into the expression. By that I can write it like this. So 25, you just take it as a numeric, and 0 minus 150 means minus 150 only. So don't get confused. If you are in rush, it becomes, the whole term becomes 0. So whole term becomes 0 has no meaning whatsoever. So please take care of the steps. By that one can easily get the problem right. So 25 into minus 150 into 10 to the power minus 3. You skip this, anything plus anything added as 0, it left out with the same term. So divided by 2 in this expression. So V2 which is equal to simply 2 ones are 275s are minus 75 into 25. It can be written as 25 into minus 75 into 10 to the power minus 3, that much of meter per second left out with in the end. Therefore V2 is equal to minus 1875 into 10 to the power minus 3 meter per second. So this means V2 1875 divided by 10 to the power plus 3 if you are taking it. So it becomes 1875 divided by 10 to the power 3000 means you will left out with minus 1.875. So 1.875 meter per second. So V2 will be minus 1.875 meter per second. This will be the recoil velocity of the pistol. Here in this part, I am just making a suggestion or giving the suggestion that make use of the previous values of these M1, M2, U1, V1, U2, and we got V2. Okay, if you substitute all these into the expression, that is M1 U1 plus M2 U2 which is equal to M1 V1 plus M2 V2, if you substitute all these values into this expression, you will find the result as 0. So that will be the conservation law of conservation of linear momentum. So you take it as homework and try to get the 0. Okay, so this is the small thing I am leaving at. So I am going to pause here at this point of time. with the new topic. I am in front of you in the next period. Till then, take care of yourselves. Bye bye.